All right, we're going to do some basics on light, reflection, and mirrors. And so this would be your electromagnetic spectrum and light basics. Facts about light. One, it is a form of energy. That energy is called electromagnetic energy. It's part of the electromagnetic spectrum. And the electromagnetic spectrum, the only part of it that we can see is the visible light. But there's a lot of things on the electromagnetic spectrum which make it important. And you do need to know the order of the electromagnetic spectrum. You know the order of the visible light spectrum. You need to know the various characteristics. So the way that I remember the electromagnetic spectrum, which goes radio waves, microwaves, infrared, then visible light, ultraviolet light, X-rays, and finally gamma rays. And I gave kind of an example picture of everything. Believe it or not, your cell phones also work on microwaves, just so you know. I always remember that infrared comes before the visible light spectrum because the visible light spectrum is known because of our Roy G. And that Y does not look good. There we go. Roy G. Biv. Okay. So I always remember that infrared comes right before red, in front of red, infrared. And then ultraviolet light is after violet. So I always remember it that way. Now, a way to think about it on the electromagnetic spectrum, also something you need to realize, is that we have longer wavelengths and lower frequency and lower energy when we go to the radio waves. As we move across the spectrum from left to right, we get um, we get higher frequency and higher energy. Actually, the wavelengths, though, decrease as we move from left to right across. Notice how those arrows interact. Something to realize is these two are inverse of each other, and that has to do with the formula because the speed of light is frequency times wavelength. And we talked about that when we dealt with the speed of sound previously in physics. So as the frequency goes up, the wavelength has to go down because the speed of light stays consistent. It's always the same. And that value is on your formula chart, actually. So if you look at the front of your formula chart, you'll notice that in your constants and conversion section that it says the speed of light, which has the letter of c. So we'll sometimes say c equals f times lambda now. And that c value is 3 times 10 to the 8th meters per second, which I have on the next slide. It is constant in a vacuum. Now it does change a little bit in certain mediums, but it's primarily going to move its direction, but it will change a little bit in its speed. Now the three things that can happen to light, it can either be reflected off of an object, which we see in mirrors all the time. It can be absorbed. So if you're wearing something black, by the way, it absorbs it. And or it can be refracted. So the light that we actually see coming through the window has been refracted, and it's actually come from the air outside. It's refracted when it comes into the window and when it leaves the window, and then it goes back into the air. So when it changes mediums, it refracts. Okay, so reflection really is just bouncing off of something. Absorbed is going to mean that it goes into and stays in there. And then refracted means it's going to pass through a barrier change from one medium to another. So light is interesting in the fact that it's an electromagnetic wave. So it's an electric wave and a magnetic wave. So it has wave properties, and those can be influenced by electric and magnetic fields. Actually, light has something called duality, and that's because we can sometimes think about it as a particle, and we can also think about it as a wave. Most of the things that we're going to talk about in this first part of the unit, we'll be talking about light as a wave. When we get into quantum, we'll talk about it more as photons, which are more packets of energy. So that's talking about it more as a particle. So light has some interesting facts about it that way. Now, there is a basic law of reflection that you're expected to know, and we will actually do a lab about this because it's really, really, really important. The law of reflection states that the angle of incidence, which is where the incoming ray comes from, equals the angle of reflection, and that's coming off the reflected ray. There's something we always call the normal line. This is the normal. And if you remember, our normal forces had to be perpendicular to the surface when we talked about forces. Well, the normal line is always going to be perpendicular to a mirror or a lens surface when we have a normal line. And when you measure angles, you always measure them from the normal line to the ray, the light ray that we're talking about. So it's real important that you follow this rule. So the law works on flat plane mirrors only. Um, the angles are measured from a perpendicular line, like I said, to the surface called the normal. So we will always just make that normal in the middle of the intersection where the light comes in and goes out, and then we will measure those angles accordingly. So our angle of incidence is measured from the normal over to the incident ray, and our angle of reflection is measured from the normal over to the reflected ray. Okay. Now a plane mirror. Suppose we have a flat plane mirror mounted vertically and a candle is placed 10 centimeters in front of the mirror. Where is the image of the candle located? This is really important to think about because all of you look in a mirror in the morning when you get up. And so when you look at your image, you need to think about, where is my image actually? Where is that image located? Is it located in front of the mirror? Is it located on the mirror? Or is it located somewhere behind the mirror? Those are really important things to kind of think about. And the way to really think about it is, when you look in the mirror, do you see all the stuff that is between you and the mirror in the mirror also image? So for example, like when I stand in front of my mirror, I have my sink and I have all my, my toothbrush, and I have my moisturizer. I have all those things in front of me. When I look in the mirror, guess what? Right behind the mirror is my moisturizer and my toothbrush, and then it's my sink, and then it's me. And that is because on a plane mirror, we don't see the object on the same side. We don't see it on the surface of the mirror. We actually see it behind the mirror. How far behind the mirror is it actually, though? Believe it or not, it is exactly the same amount of distance. So the distance to the object and the distance to the image, these two things right here, are exactly the same. Notice the heights of the image are the same as well. That's because we don't look taller or shorter. Thank goodness I can't look any more shorter. But I don't look any taller when I look in a normal plane mirror either. So those are important things to understand. This is called a virtual image, and we'll talk about those types of images in just a minute. But it's important to understand that that is a virtual image. So virtual images, what are they? A virtual image is basically images which can't be projected. That's going to be a main thing to understand. And the reason it can't be projected is because the light rays don't actually come together on the opposite side where that image is formed. If this box right here on the side, on the left side of my screen right here, we could project an image of this box onto a screen, provided the screen was on the same side as the box, but we can't get a screen on that side, so that won't work. Okay, so you wouldn't be able to project the image of a face or your face in a mirror screen. Therefore, it is called a virtual image because the light rays don't really come together. They reflect. Okay, so these are all reflecting into your eyes, so you see them, but they look like they are over here. So we'll talk about how that works and how that image forms like that. Another thing that you need to understand, so really, virtual images are always on the opposite side of a mirror relative to the object. That's going to be really important. They're always on the opposite side of a mirror relative to the object. The other thing that they always are as well is they're always upright. Okay? They are always upright. So if my image starts, they're always the same orientation. Maybe I should say it that way. I don't really like to say upright. They're always the same orientation as the object. So same orientation as object. Okay. Now, real images, though, are a different type of image. And real images are ones you can project onto a screen. And for mirrors, they are always going to appear on the same side as the mirror. So this curved image right here is my mirror. Okay, so it curves. And I have my object as an arrow, and I'll always do my objects when we draw these ray diagrams as arrows. And so this is my image actually down here, and we'll talk about how these get created. But when we do these types of ray diagrams, we'll be able to talk about the characteristic of the image. But it is always going to be on the same side. Also, it will be have an opposite orientation. So as you can see, my original arrow or my original object is pointing upwards. My image arrow is pointing downwards. So it has an opposite orientation. Now, when we get images, there's always characteristics that we can talk about, okay? So those characteristics that we will talk about are going to be its size. Is it bigger, larger, or the same size? Is it is its position? Okay, is it on the same side as the object or is it on the opposite side? And its orientation is going to be, is it right side up or upright or is it inverted? So what if the mirror isn't flat? What if it is curved instead, like my example picture here? And that's going to get into a whole different ball game, and we're going to learn a lot about curved mirrors. The big mirrors in my classroom, guess what? Those are curved mirrors. So we're going to learn about them. So everybody's always like, why do you have those in the class? It's for these units when I teach light. Okay. So we have spherical mirrors, and we do have concave and convex. So if you think about them as a big yoga ball, you can think about spray painting it with like shiny paint on the inside versus the outside. If we spray it on the outside and then cut a piece off of it, we end up with a convex mirror. This is also going to be known as a diverging mirror. You really need to learn it that way instead of as concave and convex, but I like to teach it both ways. Then if I spray paint the inside of it and cut a piece of that yoga ball off, then I get a concave mirror, which is also known as a converging mirror. And they're known as diverging or converging because of what they do with the light when it bounces off of it. It will either spread out, which is diverging, or it will come together, which is converging. So that's going to be important to understand. All right. So a converging mirror is a mirror where it's spherical in nature and it can focus parallel light on a single point of its surface, directly in front of its surface. That single fixed point we will call the focal point. To find this point, you must use light like from infinity. Infinity doesn't really mean it's like infinite, infinity away. It just means that it has to come from really far away so that all the light comes in directly parallel. Okay, so really something like the sun. The sun's really far away. So you could use sunlight to figure out where a focal point is. So this C actually is the center of curvature. So if I drew this as a big circle, that would be the center of the circle. And then my focal point is there and it's labeled with a giant F. We're going to deal more with these specifically in class. So come prepared for that. And we'll go from there. Let me see what happens in this next one. Yeah, it's a formula. So, um, so that center of curvature is 2f, so it's like the radius of the circle. And then the f value is actually 1/2 of the center of curvature. Okay. We also draw a line, though, through the center of the mirror, and we call it the principal axis. That's going to be important to understand. So we have some vocabulary words there of the focal point, the focal length, your center of curvature, and your principal axis. So kind of look over the slides, make sure that you know those vocabulary words, and be ready for class.